Hello, my name is Vadan Elkansu. In this video, I'm going to explain my Bilkent Physics 101 project report. I'm a second year computer science student and my section is 1. The title of this experiment is Conservation of Angular Momentum using an Airtable. So first of all, let's watch the experiment. As you can see, we have two pucks. One of them is steady at the origin, and we will define the point of its position to be the origin. And the second one, we tied it with a rope, with a string. This string is inelastic, so because we need to calculate the radius, so we don't want to be lengthened during the process. And I throwed it away in such that way it will do a circular motion, a centripetal motion. And as the puck rotates around the origin, the rope will actually wrap around the pole in the middle. So the radius will be slower and slower. So since the radius is decreased, and we can observe that the velocity is increased during the process. So since there is no external torque in the system, it's approximately none of external torque. So we can define in that position a angular momentum. As you can see, this is my spark timer's application to the paper blow. So you can observe this spiral-ish thing. So I set it up the spark timer at 50 milliseconds. So for 8 points, I'm gonna calculate the interval of them, the distance between them, and the radius to the origin. You can see there is a point in the middle. So as I said, there is no external torque in the system, so we can say from point 1 and 2, 4.1 and 2, L1 equals L2. So if we open up the formula, since it's very hard to calculate with the omega, with the angular speed in this experiment, we are going to use the MVR type of this formula. So MV1R1 equals MV2R2. Since it's the same puck which is rotating, we can divide the m's and we get V1R1 equals V2R2. So I've calculated, I've measured distance between two pins. I actually set it up 8 points, 8 from 8 different locations, and the two adjacent ones. So you can see the distance. For velocity, since spark timer will drop a point in every 50 milliseconds, it will be divided by that to calculate the velocity. It's called average because we cannot calculate the instantaneous velocity. So as you can see, and we don't need actually the angular momentum unit. We just need the VR to be constant during the process because it's the same object. As you can see, and we have an error of 3.3%. So that was my experience. Thank you for listening to me.